Hey everybody, let's greet each other properly. Good morning. Hey, this is Mr. Ainsworth, and we're getting into a lesson here called Solving Systems by Elimination, okay? And our goal is going to be to solve a system just like we have earlier in our lessons. However, we're going to switch methods from substitution to what's called elimination, okay? So we want to solve the system by elimination. Secondly, we're going to state the solution as an ordered pair, okay, and we're also going to verify the solution as well, okay. So number one, we're going to solve it. Number two, we're going to state it as an ordered pair, which means, x comma y. And then third, we're going to verify and check the solution here. And we could, if we wanted to, we can also check this on the T83 or some graphing software. Okay, so we're going to do a lot. Let's go ahead and get started here. Get your red pen out and annotate as we go. Okay, and let me say first that when you're looking at a system like this, which is in standard form, notice that the x's are lined up, okay, in a vertical fashion, and then the y's are also lined up in a vertical fashion, and so are the constants on the right-hand side. Okay, and a systems in standard form, such as these two right here, really lend itself well to what's called the elimination method, okay? And the goal is to eliminate or get rid of one of the variables and solve for the other one. And it doesn't matter which one you eliminate first. It depends on the system, what's easiest. And we'll talk about that throughout all the examples as we go. But in this case here, in this system, you notice that the x's here are opposites of one another. Negative x is the opposite of x. The key to this system, let's put it down on the left-hand side, is to find or create opposites. Find or create what are called opposites. All right, we know that opposites always cancel out to zero, and so if we either find a pair of opposites, like I see a pair of opposites in the x's here, we can add the equations by combining like terms, x's with x's, y's with y's, constants with constants, in such a way to eliminate one of the variables. In this case, what we're going to do is we're going to eliminate the x's. So let's bring the equations over here on the right-hand side where we do all our work. I'm just going to bring it right over here. We have x plus 5y equals 12. And what we want to do is we want to eliminate, okay, eliminate the x's. So let's write that down red. Eliminate the x's. In this case, the x's are easy to eliminate by addition. We're going to add the equations term for term, okay, like terms, and we're going to add them vertically, okay. Add the x's, negative x plus x, that cancels to 0. You can cancel them out like that, I guess, if you like. Adding the y's, negative 7y plus a 5y is a negative 2y, so plus a negative 2y. And then add vertically here, negative 20 plus 12, well, that'd give you a negative 8. Of course, 0 plus negative 2y is just negative 2y equals negative 8. Divide by negative 2, and solving for y, you get y equals 4. Okay, now, in any system, the solution is an ordered pair. You have to solve for both variables, x and y. And so once you find the one variable, you got to find the other one. And you do that by substitution. So you pick one of the equations here, and typically you can pick either one. However, pick the one that's easiest to deal with, preferably without all the negatives. And in looking at it, it's got to be equation number 2. So to find x here, we're going to use equation number 2, or what the second one, in other words, okay? So I'm going to bring it over here, x plus 5y equals 12. And what we're going to do is we're going to take our y value and we're going to substitute it in. And we're going to find the other variable. And you should be familiar with this because we've done this before in the previous methods. We taught the substitution method first. All right, so this should sound familiar. And so what we're going to have here is we're going to have x plus 5 times whatever y is equals 12. So I need to substitute that y variable in, okay, or y value in, which is y equals 4. All right, then you just simplify and you go with the flow. We have x plus 20, 5 times 4 is 20 equals 12, subtract 20, all right, and we get x is equal to negative 8. So as a solution here to the system, we have it's always x comma y, and in this case we have negative 8 comma 4. The question is, how do you know if you're right? So let's talk about that. We solved it we state it as an ordered pair, but how do you verify it? Well, you verify it and you check your solution here, all right, by substituting into both equations, all right, into both equations. So what we want to do is we want to substitute this in here, also in here, one at a time. So let's go for it, okay? And if it is correct, and if we did find it correctly here, then it should satisfy both equations because the intersection point lies on both lines, and it should satisfy both equations. So I need to substitute negative 8 in for x, 4 in for y, and see what happens. So I got negative of whatever x is minus 7 times whatever y is. Is that equal to negative 20? I don't know. Let's figure that out. So let's substitute negative 8 in for x. Right here, there's my substitution. Substitute y, or 4 in for y, and you simplify the left-hand side. So I know a negative of a negative 8 is 8, minus 28 here. Is that equal to negative 20? And the answer is yes, because 8 minus 28 is negative 20. And negative 20 equals negative 20, so it checks out. We say that it satisfies this equation, which means that it is a point or a solution of that equation. But to be a solution to the system, it has to satisfy both equations, not just one, okay? Hence the word both equations. So is negative 8 plus 5 times y, and this is a 5 here, times y, which is 4, is that equal to 12? I don't know. Let's find out. So is negative 8 plus 20 equal to 12? And the answer is yes. 20 minus 8 is 12. And so it's a solution to the second equation too. So we can see that our ordered pair, negative 8 comma 4, is actually correct because it satisfies both equations in the system. And you check that by substitution. All right, nothing new because we've done that in our graphical method, we've done it in our substitution method, and now we've done it in our elimination method. So you should be pretty familiar with that up to this point. Now let's get some experience here, and let's take a look at some other systems that aren't quite so simple as the first one here. And I call this first one a simple one because the opposites were given to us, okay? The x's were already opposites. But sometimes, and most of the time, that's not the case. Like in system number 2 here, 4x is not the opposite of 4x, and nor is negative 3y is not the opposite of 2y. So we don't have any opposites. So once again, I'm going to say create opposites. This is the goal. And there are many ways to do this, and it relies upon your creativity and your number sense. All right, so what we want to do is multiply one of the equations by a number to create opposites. So for example, what's the opposite of 4x? Well, it's obviously negative 4x, right? So the question is, what would you multiply the second equation by to make this first term negative? Well, and the answer is negative 1. So we can take this equation here, multiply it by negative 1, and so it becomes the opposite of 4x. So I'm going to rewrite the first equation over here. I'm just going to bring it over so we can work on it. I'm going to multiply the second equation by negative 1, so it means times negative 1. And when you do that, you multiply all three terms by negative 1. So negative 1 times 4x is negative 4x. Negative 1 times 2y is a negative 2y. And negative 1 times negative 18 is positive 18. And then you add the equations vertically. Add equations, all right, vertically. Okay, that's all you do. Okay, and so 4x plus a negative 4x, that cancels to 0. You can put a 0 there if you like. Negative 3y and a minus 2y is a negative 5y. And negative 13 plus 18 is 18 minus 13, which is 5. So divide by negative 5, all right, and y is equal to negative 1. And like all systems, you got to solve for both variables, right? So what you want to do is want to find x now, and you get to pick your equation. I'm just going to bring over the first one because it doesn't matter which equation you use. They're about the same level of difficulty. And what we want to do is take negative 1 and we're going to substitute it in for y. SUB for substitute. Okay? And so what we have here is 4x minus 3 times negative 1 equals negative 13. All right, let's simplify. 4x plus 3, negative 3 times negative 1 is 3. That's equal to negative 13. Let's subtract 3 here, and let's solve for x. Okay, negative 13 plus negative 3 is a negative 16. Okay, add vertically. All right, divide by 4, and you get 4, or excuse me, x is equal to negative 4. So my solution here as an equation, or as an ordered pair, excuse me, is negative 4, always x first, comma, negative 1. Okay? And so you do that, well, let me go back to the very beginning. You just have to find a number to multiply one or both the equations by to create opposites, and that is the key. All right, you want to find or create opposites. If it's not already given to you, well, then you create them by multiplying the equation by some number. Just involves a little creativity, a little bit of number sense. Like in this next one here, the opposite of 3x is negative 3x. So if you want to eliminate the x's, you can multiply this one by 3. Same thing with the y values. I see negative 9y here. So if you want to eliminate the y's, I would multiply this second equation by 3 because the opposite of negative 9y is 3y. So let's multiply this one by 3 times by 3 here. And the first equation I'm just going to bring over. I'm not going to multiply it by anything, so we're just bring it over. Multiply each term, all three terms, by 3 here. So you get a negative 3x. 3 times 3y is 9y. And right here, 3 times 4, well, that's 12. Okay, add vertically. Okay, and got a 0 here, and that equals, that equals 0. So 0 equals 0. That's obviously a true statement, but what in the world does that mean? Well, let's remember that from our earlier lessons here, whenever a system ends up like this, or whenever you algebraically solve a system where you end up with a true statement, where things cancel out, like the variables cancel out, and you get a true statement, that means an infinite number of solutions. It turns out here that these are really the same equations, and the lines overlap at an infinite number of points. So when you ever have something that ends up in a true statement here, we respond by saying an infinite, number of solutions, because they're the same equations. All right. So sometimes we have a solution, and if so, we state it. Sometimes we have an infinite number of solutions, and sometimes we don't have any solutions at all. There's 3 different types of systems you can have. And there's different ways you can eliminate variables. So let's go ahead and get some more experience here, and let's take a look at the next 3 examples. Now let's change things up a little bit. Let's eliminate y's, just for funs. So not that you have to, but I'm going to change up the lesson here. So let's eliminate the y's. Let's take a look right here. Now, the coefficient here is negative 1y, and the coefficient here is negative 8y. So I want you guys to get your eyes on these terms, these y terms, and just think to yourself, what's the opposite of negative 8y? Well, it's positive 8y, right? So we can multiply the first equation by negative 8, all right, and then add it to the second equation. Or we can multiply the second equation by negative 3. So I'll tell you what, let's go ahead and eliminate the x's instead, because it's going to be smaller numbers and probably going to be easier to deal with. So let's change gears. Let's eliminate the x's here, and let's take a look at this. So opposite of 15x is negative 15x. So in this case, all we have to do is really multiply this by negative 3 and by negative 3 here. And to eliminate the x's here, I think that'd be a whole lot easier because the numbers are smaller. You can do everything in your head. So let's bring the first equation over here. And the second one, we got to multiply everything by negative 3. So negative 3 times 5x is negative 15x. Negative 3 times negative 8y is plus 24y. And negative 3 times negative 13, that's just 39. Add vertically. Opposites always add to 0. And you get 24y minus y is 23y. And negative 16 plus 39 is 39 minus 16. 39 minus 16, and that's 23. So you get 23 here. And since 23 times 1 is 23, y has to be 1. All right, not too bad. So you can tell that, sometimes it's fairly straightforward here. Now you just got to find the other variable. All right, so let's bring the first equation over here and let's do that. So 15x minus y equals negative 16. We're just substituting our value in here. We get 15x minus 1 equals negative 16. Oh, by the way, this reminds me here. This is a video, right? So if you guys are thinking that I'm going a little too fast, well, hit the pause button, rewind it, slow me down. The advantage of the video is learning how to use it. Pause and play throughout and go at your own speed. All right, pause and play and go at your own speed. So let's continue. Let's add 1, and we get 15x is equal to negative 15. Okay, and then you divide by 15, and you're going to get x equals negative 1. So the solution here on this one is always x and then comma y. It's going to be negative 1 comma 1. So negative 1 comma 1. Okay, it's not too bad. And just remember, you're creating opposites. I'm going to write that down again. Create opposites, and that's the key. So write down the key concept and get creative. Pick any number, multiply the equation by it to create an opposite. You can eliminate any variable you want. All right. Now, continuing on here, we're going to find out in this case where you're going to have to multiply both equations by something. So this is a little bit more challenging. Okay, so let's see here. I'm going to switch gears. I'm going to eliminate the y's here this time. So let's write that down. So eliminate the y's. So let's focus in on those. Let's take a look at right here. And I know that 4 times 9 is 36. So knowing that, I can get one 36 and one negative 36 pretty darn easily by using the numbers 4 and 9. So if I multiply the first equation by 9, I get 36y here. If I multiply the second equation by 4, I get negative 36y down below. So using the original numbers, I can find and create opposites pretty easily. Okay, so I'm going to do that. Here we go. So my first equation here, we're going to multiply it by 9. So times by 9. So I get 9 times 3x is 27x. 9 times 4y is 36y. And then 9 times negative 10 is negative 90. The second one I want to multiply by 4. So 4 times 2x is 8x. 4 times negative 9y is a negative 36y. There are the opposites right there. And then 4 times 5, that's just 20. And then you add vertically. Okay, so 27x plus 8x is 35x. These cancel out. So plus 0 here, all right, is equal to negative 70. Well, that just gives me 35x equals negative 70. And if I divide both sides by 35, I get x is equal to negative 2. Whoops, negative 2. You can check that with your calculator, okay? 70 divided by 35 is 2, but I see a negative sign, so I said negative 2. All right, then you got to find y, so let's do that. Once you find one of the variables, you got to find the other one. So I'm going to use the second equation. So 2x minus 9y equals 5. I want to take this x value now and substitute it in for x. Close the door. All right, so what do we have? We have 2 times negative 2 minus 9y equals 5. That gives me negative 4 minus 9y equals 5. Add the opposite. I get negative 9y equals 9. And since negative 9 times negative 1 equals 9, I know y is negative 1. Okay? Or you can simply divide if you want, and you can see y is negative 1. So the solution on this one is negative 2 comma negative 1. All right? And that's all there is to it. Get creative and find and create opposites. So let's write that down again because this is the key to the method here. Create opposites. And if you could do that using your number sense, then this method is an awesome method here. It really works well through its standard form. I wouldn't use this method if the equations are in different forms, but like if, for example, if one's in slope-intercept form and one's in standard form, I wouldn't use this method. I'd use substitution, but here this lends itself really well. Okay. All right, last one here. Let's let me see. I can make one, if I want to eliminate the x's, I can make one 12x and one negative 12x. That'd be really easy for me to do. Or if I want to eliminate the y's, I just have to multiply the second equation by negative 2 to make that a positive 6y, the opposite of negative 6y. And exactly that's what I want to do. I want to eliminate the y's because I think that'd be easier. I always do the whatever's easiest and requires less work, right? Be efficient, okay? Not that I'm lazy, it's just that I want to be efficient. So here we go. Negative 6x minus 6y equals 6. I want to multiply the next one by negative 2. So times by negative 2. And let's see. Negative 2 times negative 4x is 8x. Negative 2 times negative 3y is positive 6y. They're the opposites right here. Negative 2 times negative 4 is positive 8. And then you add vertically. So we've got negative 6x plus 8x, or 8x minus 6x is 2x. These cancel out, and you get 14, so you get 2x equals 14. So x has to be 7. Okay, then you pick one of the equations and you use it. So I'm going to pick, I don't know, the first one, I guess. It doesn't matter which one you use, you get the same results. So just pick an equation and run with it, right? So you got to substitute in for x here. Why? Because it's equal to x, right? So you get negative 6 times whatever x is, which is 7, minus 6y equals 6. That gives us negative 42 minus 6y equals 6. Add the opposite. You get negative 6y equals 48. And after you divide by negative 6, you get y equals negative 8. So the solution on this one is 7 comma negative 8. Now, like I said, this is a video, and if I went too fast, which I probably did for some of you, rewind it. Listen to it a couple times. Finish taking notes, rewind it, listen to it a couple times, pause and play. Pause and play. Okay, sometimes rewind. All right, and listen to it. Listen to the video multiple times. That's the advantage of the video, is that you can go at your own pace, listen to it again, review, and do whatever it takes to be successful. All right, so there you go, guys. There's the elimination method. Now you just have to get to your practice, which is associated with this, and practice and check your work as you go. And I'll see you in my next lesson. This is Mr. Ainsworth signing off. I'll see you.